going to talk about how to solve systems with three variables. So you may remember when you're solving systems with two variables, typically you have an x and a y, and those are your only two variables. But in this case, we're going to throw on a z as well. And when we find our answer, we're looking for basically the point where these three-dimensional lines would meet up. So you could almost think that if this were a graph, you would have an x and a y, and this isn't exactly z, is usually the one that comes out of the page, but you would have another axis that would kind of come out of your paper. So we're looking to see, where three lines that we would happen to have would cross. So I'm going to use the elimination method for this. There's a whole bunch of methods you can use, matrices, Cramer's rule. There's a whole bunch of ways you could solve this, but for this one we'll stick with elimination. So the first thing to do is look down at your variables and see which variable might be the easiest to eliminate in all the equations. And looking at this one, I would say probably the y's and the z's are a good bet, so I'm just going to pick the y's for this one. The z's are also a pretty good bet as well to eliminate all the variables. But if I look here, I've got a -2, a y, and a 6. They're all kind of easily common multiples. The x's are kind of a bad choice. You're going to have to multiply both equations by something in every pairing to try and get these to work. So what we'll do here is I'm going to label these equations 1, 2, and 3. And that's just going to help me out here to identify what I'm doing. So what I'm going to do is I'm going to try and cancel a variable in two different pairings of equations. So if I decide that I want to cancel the y's, what I'm going to do is, let's say we'll take equation 1 and equation 2. So I'm going to say, let's take equation 1. And I would have to multiply this one by 2 to get the y's to cancel. So I'm going to say plus 2 times equation 2. So if I do that, if I doubled this second equation, that should cancel the y's. Okay, so this should cancel the y's in one of the equations. So I'll have -6x. This one's going to stay the same. This is equation 1. Equals -17. And then this second equation, if we check it out here, if we doubled everything in here, we'd have 10x plus 2y. That's what I want, so the y's cancel. Minus 12z is equal to 38. Okay. And now if we go ahead and solve, the y's should cancel. And this would give me 4x. This would be minus 13z is equal to, this should be 21. Okay, and that should get me down to a system now of two variables. Let's call this equation 4. Okay, so I'm going to circle that and I'm going to call this equation 4. And now what I'm going to do is I'm going to get a fifth equation from here that's also only down to x's and z's and solve that. So I'm going to have to cancel the y's in one different pairing here. So since this one's kind of easy, I think I'm going to stick with, yeah, you know what, actually I might take that first equation. So I'm going to take equation, we'll say -3 times equation 1. That should get me a +6 to match up with the one in equation 3. So I'm going to take -3 times equation 1 plus equation 3. Should also now get something to cancel. You might have to multiply both by something to get a cancellation, but let me kind of leave a little space here so I'm not mixing up my work. So now if I do this, again, I'm going to set this up. We'll have -3 times equation 1 should be 18. Positive 18x, I'm just multiplying everything in that first equation by -3, plus 6y plus 3z is equal to, that should be 51. And then if we look at equation 3 and we add this in, we'll have -4x. Just going to keep this one exactly the same. Fortunately, didn't have to multiply both equations by something on this one. Makes it a little easier. So now if I go ahead and combine, 18 minus 4 gives me 14x. The two y's here should cancel, so we'll cancel these out. And you know what? Let's go stick with my color scheme. We'll make this a green here. So this would be 14x. This would cancel out. So 3 minus 6 should be -3z. And that should equal 51 minus 20 should be 31. Okay, and now if you notice, I'm down to a system of equations here that only has two variables. So I'm now going to start working with equation 4 and equation 5. All right, so what I'm going to have to do now is try to find a way to get either the x's or the z's to cancel, and then I should be able to solve for one of my variables. So I think what I'll do, let's get these both to be 28 on the x's, one 28 and one negative 28. So I'm going to take this top equation by negative 7. So I'm going to take negative 7 times equation 4, and I'm going to add to that, here's equation 5, I'm going to add 2 times equation 5, and that should get me kind of my setup there. It's helpful to kind of list this stuff out to keep yourself organized. So now taking this negative 7 times equation 4, that should give me, let's go ahead and calculate this. If we go down to equation 4, negative 7 times the 4 should give me negative 28x. Negative 7 times that negative 13 there should give me a 91z positive, because we have to flip that sign since we multiplied by negative. And then negative 7 times 21 here should give me a negative 147. Okay, so that takes care of equation 4. Let's go ahead and look at equation 5. So we have to double this equation. We should be getting positive 28x minus 6z is equal to 62. And now we're all set up to go here. So this should look something like you're familiar with, where we're canceling, and we should get an 85z here. And actually the nice thing here is that if we kind of subtract these two, this will give me a negative 85. And dividing by 85 on both sides, we're going to get that z is equal to negative 1. Okay, so that's our first kind of piece of our answer. And actually when we write these ordered pairs for our answer, we're going to actually have an x, a y, and a z coordinate. So when we write our answer here, the z coordinate we just found is negative 1. Okay, so that gives us kind of a piece of our answer here. What we're now going to have to do is pick either the top or the bottom equation. I'll probably pick this one, it's easier. And then what we're going to have to do is try to plug things in and then solve for the other variables from here. So we're going to go back to 4 and 5 now, where there were only 2 variables to find the x. And once we found the x and the z, we're going to go all the way back to one of the original equations to find the y. So let's go ahead and do just that. I'm going to take equation 5 here, and I'm going to say, okay, so this should be 14x minus 3 times, I'm plugging in the z now, for negative 1. There we are. And we would have 14x plus 3 now equals 31. And if I subtract that 3 over to the other side, I should get 14x equals 28. So if I divide by 14 on both sides, that should give me that x is now 2. So now I found another coordinate with x equals 2. So finally, we just have to pick one of the equations here at the top and plug in our variables to see what we get. So I think I'll pick this one here. We're going to plug in the x and the z that we found, and we'll solve for the y here to see what our final coordinate is. So we'll go ahead and wrap up with that. Alright, I'm running out of room, so I think what I'll do is I'll make a little space right in here to show this work. Okay, so if we have our 5 times that 2, I'll fill in a second, plus the y that I'm trying to find, minus 6 times the z that I'll also fill in a second here, equals 19. So we know that our z was negative 1 and our x was 2. So this should give me 10 plus y plus 6 equals 19. And that's really all just going to be 16. So if we take y plus 16, that equals 19. And if we subtract the 16 over, we should be getting that the y coordinate is 3. So actually we're here now. So we just found our final answer, that the coordinate would be 2, 3, negative 1. And we just found that if this were a three-dimensional, graph that we were looking at, that all 3 of these lines would meet at the point 2, 3, negative 1, wherever that would be on your axis. And now that we've got that point finished up, that's all you have to do. The only thing I would recommend is checking your answer. You would have to plug in 2, 3, and negative 1 for the x, the y, and the z, not just in one equation, but actually in all of the equations to make sure that that's true.